So see here, last class we have finished resolving power of I. Okay, and I think I told you to do an activity. I hope you have finished that. So let's go to the next point, that is resolving power of microscope. Resolving power of microscope. On this we will solve problems also. Okay. Now let us assume that this is objective lens of a microscope, and here I am keeping one object, that is O. Now the image of this object we will get somewhere here, and let this angle be alpha. Okay, now another point object I am keeping here, that is O dash, and let us suppose this distance is how much? X m. Okay, this distance is what? X m. This is point m and this is n. Now this is what I, image of this object O. Now here is O dash, where we will get its image. Somewhere here. Okay, I dash. Okay, now Mn is what here? Mn is aperture. Mn is aperture means what? Area through which light enters. Aperture of lens, we can say, that is objective lens. And due to diffraction, I and I dash are surrounded by alternate dark and bright diffraction rings, we can say. The two images are said to be just resolved if the position of central maximum of I dash corresponds to the first minimum of image I. Now, the path difference between extreme rays from O dash on reaching I is 2xm sin alpha. कहां से देखो, path difference between extreme rays, क्या लिख रहा हूं मैं, देखो, path difference between extreme rays from O dash on reaching I is 2xm sine of alpha. If this path difference 2xm sine alpha, if 2xm sine alpha is equal to 1.22 lambda by mu, then center of I corresponds to first minima of image I dash. Corresponds to first minima of I dash. First minima of I dash. And two images just resolve, appears just resolve. Therefore, xm is equal to 1.22 lambda divided by 2 mu sine of alpha. And what is xm here? Xm is resolving limit. Resolving limit means the distance between two objects we cancel. Xm is what? Resolving limit. And next one, resolving power is equal to 1 by xm, which is equal to 2 mu sine of alpha divided by 1.22 lambda. In this formula, the terms which are involved that are very important. Mu is the refractive index of lens. Okay. Mu is what? Refractive index of lens. Next, mu is refractive index of lens or medium. 1 minute. I will write here. Mu is nothing but it is the refractive index of medium, not the lens. Refractive index of medium between object and the objective, not the lens, object and objective lens. मतलब समझो यहाँ पे air है, O dash and lens. In between this, whatever the medium is there, its refractive index is mu. Okay, and sin alpha is numerical aperture. Sin alpha is what? Numerical aperture. Lambda is wavelength of light. Lambda क्या है? Wavelength of light. Wavelength of light. And alpha is, or sin alpha we can say, sin alpha is numerical aperture. ना इसके ऊपर जो प्रॉब्लम्स है ना वो हम सॉल्व करेंगे तो हमें थोड़ा सा ज्यादा समझ में आएगा. एक बार ये नोट डाउन करो. Just note down. Yes, finished. यहाँ पे जो डायग्राम में एक काम करो, ये जो अल्फा एंगल है ना, ये बस यहाँ तक ड्रॉ करो, एक चेंज करो, ये जो अल्फा एंगल है ना, इधर तक, ये खाली इधर तक चेंज करो, यहाँ तक। ओके, ये बस यहाँ तक ही, ये वाला एंगल बस इधर तक ही करो। ठीक है, चलो आगे बढ़ते हैं प्रॉब्लम की तरफ। A microscope has objective of aperture 8 mm and focal length 2.5 centimeter. Estimate its resolving power. Estimate its resolving power. Given that lambda is equal to 5,500 angstrom. Okay. अब ये कैसे करेंगे देखो प्रॉब्लम। A microscope has objective of aperture 8 millimeter and focal length 2.5 centimeter. Estimate its resolving power given that lambda is equal to 5,500 angstrom. बहुत इजी, आप लोग कर लोगे। एक मिनट रुको, थोड़ा सा हिंट देता हूं मैं। See now, this is objective lens and focal length means what? This distance है ना। तो ये जो दिया है उसने, ये कितना है? 2.5 सेंटीमीटर। अब ये जो एंगल मानेंगे वो है अल्फा, है ना। एंड दिस कंप्लीट इज 8 मिलीमीटर, तो ये वाला जो पार्ट है ये हो जाएगा 4 मिलीमीटर, है ना। This one is how much? 4 millimeter, because this complete aperture is 8 millimeter. O P Q, suppose. Right. Now, if alpha is very, very small, alpha is very, very small, because you see aperture is very, very small there. Can I say that sine alpha is nearly equal to tan alpha? And therefore, sine alpha is equal to 4 millimeter divided by 2.5 centimeter. है ना? Right? 4 millimeter divided by 4.5 centimeter. ये कितना होगा देखो, करो काउंट, कैलकुलेट करो. तो ये हो जाएगा 4/25 मिलीमीटर. सही है ना? तो ये गया. तो ये कितना होगा देखो, 4/25, 0.16. ये आ गया साइन अल्फा. एंड we have to find resolving power. So what is the formula of resolving power, Ray? Yes. Resolving power formula क्या है? 2 mu sin alpha by 1.22 lambda. है ना? Yes. So can you do it now? Mu is air. Mu is for air. Can you do it yourself? Yes or no? Bolo. Can you do it yourself? Yes. अब साइन अल्फा आ गया. रिजॉल्विंग पावर फाइंड आउट करना है कि नहीं? रिजॉल्विंग पावर क्या है फॉर्मूला देखो, 2 म्यू साइन अल्फा बाई 1.22 lambda. 2 into 1 into 0.16 divided by 1.22 into lambda is already given 5500 into 10 to the power minus 10. Can you do it now? Yes. Narayan, 4.769. Okay. Any other answer? 4.769. देखो और किसी को आ रहा है आंसर? 476900. ओके, तो ये आ जाएगा 47690 ओनली. ओके, एक जीरो का मारा. चेक करो, कैलकुलेशन चेक करो. ये ऊपर गया तो 0.32 into 10 to the power 10 divided by 122 into 55. है कि नहीं? These two zeros means this 122 into 55, right? तो अब ये जो 0.32 है, इसको हम डिवाइड करेंगे 122 into 55 से. ये आ जाएगा 4.769 into 10 to the power -5 into 10 to the power 10. तो ये चलेगा, तो ये आ जाएगा 4.769 10 to the power +5. है कि नहीं? This is what resolving power. Okay. हाँ, यस, वर्षित राइट है और रामो का आंसर भी राइट है. हाँ, यस. चलो आगे बढ़ते हैं. नेक्स्ट जो है रिजॉल्विंग पावर ऑफ टेलीस्कोप. रिजॉल्विंग पावर ऑफ टेलीस्कोप. Resolving power of telescope. Right? Now let us assume that again this is the objective of telescope. Objective of telescope, and now object is at somewhere infinity, suppose. Okay. Here we are having two images. This is I dash and this is I, and this angle is, let us suppose, theta m. This is m and this is n. Now here, if small a is diameter of objective and lambda is wavelength, then resolving limit theta m is equal to 1.22 lambda by a, and resolving power is equal to 1 by theta m, which is equal to a by 1.22 lambda. This is what two formulas for telescope. Okay, let's solve one problem. Note down fast. Yes, finished. See here, problem. Calculate the smallest angle resolved. Calculate the smallest angle resolved by a telescope with an objective of with an objective of 5-meter diameter. Calculate the smallest angle resolved by a telescope with an objective 5-meter diameter. Okay. And what is the minimum magnification? What is the minimum magnification is needed to enable the human eye to utilize resolution? और उसने गिवन भी दिया है aperture of the eye. Aperture of eye is 2.5 millimeter. Okay, so let's solve. Very easy question, not that much difficult. Given क्या क्या है देखो पहले. Smallest angle resolved means what? Theta he is asking है ना. Theta is equal to question mark. objective of 5 meter diameter means A is equal to 5 meter. Minimum magnification और जो वेवलेंथ है वो दिया है क्या उसने, वेवलेंथ आप लैम्बडा इज इक्वल टू 5500 एंगस्ट्रॉम ले लो. ओके, इसके बाद लैम्बडा इज इक्वल टू 5500 एंगस्ट्रॉम. ओके, नेक्स्ट. aperture of eye also given. Aperture of eye is also one lens only, no? तो ये दिया है 2.5 into 10 to the power -3 मीटर. तो सबसे पहले थीटा फाइंड आउट करेंगे. थीटा इज इक्वल टू व्हाट रे, 1.22 lambda by a. You can do it yourself, right? It is very easy. Everything is given, you can do it. Next part, what he is asking, what is the minimum magnification needed to enable the human eye to utilize resolution? तो मिनिमम मैग्निफिकेशन ये जो है मैं कर लेता हूं यहाँ पे. मिनिमम मैग्निफिकेशन is equal to minimum magnification for human eye. Okay, for human eye I am writing in the bracket, is equal to aperture of objective divided by aperture of eye. Okay, just divide these two, you will get the answer, है ना? Okay, can you find now? Can you do it yourself? Substitute the values, do it yourself. 1.22 into 5000 into 10 to the power -10 divided by aperture of objective. कितना है, कितना है ये 5. हाँ, देखो कितना आता है आंसर. I think 1.22 into 10 to the power -7. तो ये क्या, रेडियंस. हाँ, तो ये नहीं, एक बार चेक करो रे, नीचे का ए लिखा है क्या, ए 5 है ना, ए कितना है, 5 है. हाँ, 5500 है ना यहाँ पे. रुको, ये हमने गलत सब्स्टिट्यूट किया है. इधर देखो, ये 5500 करो इसको, है कि नहीं? हाँ, दिस वन इज रॉन्ग. एक बार फिर से करो. 5500 है ना, हमने 5000 सब्स्टिट्यूट किया. तो ये 5500 into 10 to the power -10 divided by ये a 5, ठीक है नहीं? तो ये आ जाएगा 1100. हाँ, अब देखो कितना आता है. आई थिंक 1.34 10 to the power -7. सही है ना? राइट, चेक करो. हाँ हाँ, यस यस यस. उसके बाद यहाँ पे a by AE, ए कितना है, देखो चेक करो, ए कितना है आप देखो. A value is 5. This is 2.5 into 10 to the power -3. तो ये हो जाएगा 2 into 10 to the power 3. Yes, 2000. Yes, no, कितना आएगा ये, 2000 है ना? इजी क्वेश्चन है इसके ऊपर. Just this 2-3 formulas you just keep it in mind. Very easy. Easy problems are coming.